Okay. All right. Hello, everyone. Thank you for your attendance on my meetup. So today I'm going to hold this meetup, and we'll discuss and observe presentation layer patterns using Flutter. So yeah, that's me. I'm a senior mobile developer and resource manager at Andersen. So have been working as an Android developer over 8 years of experience. Also, I'm Flutter enthusiast, judge, volunteer, published a couple of materials on Medium, and yeah, maintainer of clean architecture, open source template on GitHub. So this is our plan of this presentation. First of all, we dive into Flutter. What does that mean and how it works? Before we get started observing these patterns, we'll observe a small application which allows us to see weather forecast. Then we'll dive into importance of clean architecture and mastering clean architecture, obviously. Then we'll introduce to stateful widget pattern, and because these 2 points are important to understand other specific patterns provider as well. And then we'll focus on these presentation pattern like MVP, Viper, MVVM, riverpod, MVI, Redux, MVU, BLoC. Then we'll compare these patterns and we'll hold Q&A session. So yeah, before we get started observing these patterns, let's focus on this pattern. This solution allows us to build beautiful compiled apps for mobile, web, desktop, and embedded form single code base. In the meantime, it is highly important to emphasize that we'll focus on mobile only. It also allows us to accelerate development, enable high-performance UI rendering, promote declarative programming as well, and other interesting features. So this is small application which we'll be observing with these patterns. It has a couple of states. First one is a loading state with data, weather forecast, and also we have error handling, but I missed that because of to economy this place. Actually, it has a lot of statements. The first one, fetching data and refreshing, detecting geolocation, appearing weather forecast, handling errors, clean architecture, scalable presentation part, which illustrates some patterns, localization, and cat lead service locator. Here is the importance of clean architecture. Here is the default picture, which illustrates splitting these items like entities, interface, adapters, use cases, and framework and drivers. And so there is like conception of it. It allows us to separate this concern. It allows us to test it easier, maintain scalability as well, replaceable infrastructure, and team collaboration as well as other important things. So yeah, this is the scheme which illustrates the clean architecture. So we'll focus on the presentation further, but it is highly important to say that we have a use case, which is an entry point to domain layer, which is split by entity and repository interface, and data layer as well, which has repository instance, which has linked to local storage and API service. Yeah, let's dive into clean architecture of these small applications. So first of all, it is important to say that we have a DI implementation, which is actually a service locator. Here I just registered some instances and their interfaces in order to operate with their interfaces. Here is a data source. So there's just a small response and a small API call, I just get here I just call this URL and parse some data in order to respond it. Here is the model. So not much to say, actually, just network weather, which illustrates some data for this weather forecast. And yeah, also it has a repository, so it actually has a link to previous weather service implementation, but it operates its interface. Also, it makes some checks like service enabled and permissions as well. Then I get a city, and using this network weather, I just receive this weather forecast.
I'm sorry for a question.
Yeah, sure.
For question, the service is just importing from some another libraries, or you're writing it yourself?
Libraries about API, HTTP API, right?
Mm-hmm.
So yeah, we have a library in Flutter which allows us to make some API calls like post, get, and so on. So yeah, I just use it, and here it goes to our constructor by using this interface. It has a weather HTTP API interface, and using this interface, I operate with their instance. But I do not hear about this instance. Yeah.
Thanks.
All right, let's go further. Here is the domain, which has entity. It is actually the same as from data, but it's connected with our domain layer. A repository, which I said before, but it is like abstract class or interface. And we have this use case, which, as I said before, it is kind of an entry point to our domain layer. So yeah, it has a link of our repository, and here I just make fetch weather to receive this weather model from domain. Okay, that's actually pretty about clean architecture of this application, and here is about our presentation. Before getting started observing these particular patterns, it is highly important to mention that we have key highly important things which are highly important to understand. Stateful widget-based pattern and provider. The first one allows us to rendering our UI, its lifecycle, encapsulate states inside the widget tree, and other key bullet points. While provider allows us to provide some components with using easily way. So widely used dependency injection and state management solutions, simplify state sharing across the widget tree, and so on. So yeah, it would be better to see how it works. Yeah, stateful widget-based pattern. So yeah, here is the difference between stateless and stateful. As you can see, stateless allows us to just appear some UI components, like, for example, text, without its state. Obviously, it works faster than stateful, but stateful has its own state, which allows us to listen to this state, right? So, for example, if something is changed, we call set state, which calls build, and these components through builds.
And this works for higher redundancy of your code.
So basically, yes, stateless could be used for some kind of small components which don't have its own state, while stateful one could be used for such big trees components which could listen to other states, and while this state is changed, these UI components are also rebuilt.
And that's that makes more simple monitoring of the.
Yes, exactly. Yeah, exactly. All right, stateful-based widget pattern. Here is a small example. It doesn't actually connect it with our application, which I showed you before. This is just for demonstration that we have, for example, a count. We have increment method, and as you can see, I call this setState method. Here I increment this count, and by calling this state, our function build is being called. So by using increment, we automatically call this build, and this structure will be redrawn. And here is the provider. In order to present how it works, I just decided to improve previous sample, the same count and the same increment, which calls also notify listeners, which is a part of this change notifier. So yeah, as you can see, by using this mechanism, I call the context in order to watch this counter model. This counter will be kind of an instance of counter model, and when I call this method increment, this structure will be redrawn again. And yeah, and how it could be registered in the main model. So we call just counter page, and it is highly important to mention that we call this change notifier provider. Okay, so before we focus on these patterns, I just want to ask my audience, do you have any questions which we've covered before, or we can proceed further?
No,
okay, in chats?
In chats, either.
Okay, cool. All right, so here we just observe MVP and Viper, and Flutter, MVVM, MVI, and riverpod, Redux, MVU, and BLoC pattern as well. So yeah, this is my actually state handling. It is highly important to mention that also because I avoided using these screenshots in order to make economy as well. So here is a method which listens to its loading. If it is loading, I just appear circle progress indicator. While it is, if it has an error, I make some kind of switch case with handling of these errors. And this is my actually structure which handles this weather. Refresh indicator allows us to listen to our like swipe, listen to our swipes. It allows us to fetch weather, and I just simplified other structure, just scroller and other components. Here is the illustration of MVP and Viper. So we have a view, which I just presented you, which has a link to presenter and operates with and interacts with this presenter, while presenter has a link to interactor, which uses entity and changes it. Also, presenter has router for routing purposes. Let's review this entity as simple, really one. Just it is crucial to mention that we have a UI weather model. So yeah, here is an interactor. As you can see, it has its interface with just a simple method fetch weather, which allows us to fetch it. And as you can see, previously we observed our use cases, and I mentioned that it is our entry point. So as you can see, I just used this use case to receive this weather model. And then I just using this mapper, map it to UI model. So yeah, also yeah, I use this get it. Also, again, I describe you where I register this model. So yeah, I just have this interface by using this get it, receive it implementation, and use this interface, receive other models. So yeah, here is the presenter. A couple of methods like show loading, show weather, and show error, which yeah, so yeah, which are being used. And yeah, a view and interactor, which I just presented you. So yeah, while a lot weather is being called, I just call this show loading in order to show users that something is going on, and then receive weather, show its state, or in case of error, I just appear this error. And here is the view, which I just showed you. So yeah. Yeah, here is the presenter. And here I just call this unload weather from this presenter. So while it is being called, the structure is being redrawn, and I will see all of these states as it is. What to say about MVP? Talking about strength. So yeah, I can clear separation and can clearly separate it of this concern. It could be testable. Good complex logic could be simplified, and encourages interface-driven design. In the meantime, we have some weaknesses, and so yeah, boilerplate, verbosity, not adipomic for Flutter. It means that it is hard and challenging to use this with our stateful widget pattern. Yeah. MVVM. Basically, we have a simpler concept. We have a view, we have a view model. A view knows about this view model, while view model changes this model and responds back this model to this view. Yeah, here is the view model. It has this use case, fetch weather again, just one method for which allows us to obtain this weather. Just use this fetch weather use case to receive it, then map it. If we have some kind of error, I just update this error, and that's it. The difference is we have this view model has separate properties with weather, with error, and with its loading. And this view listen to these properties in order to handle this state. Yeah. So here is the strength of MVVM. Again, clear separation of concerns, testable, scales, works naturally with reactive libraries. It is obvious. It is obviously a big advantage, and improves readability and maintainability of UI code. When it comes to its weaknesses, boilerplate again. I think state handling can become tricky without structural tooling, yes. And again, it is hard to listen to these properties because we have actually just one entry point into the state handling, while we have a couple of these properties. MVI and riverpod. Here is this illustration which demonstrate us the flow of this data. The main difference is we have like cycle looped flow. It means that the view pushes some state to user pushes some action to intent, and intent by using this intent, we update this model. And again, model goes to our view. Let's code it. So here is the state. Obviously, we have, again, a couple of properties which illustrates as loading, UI model, and exception, if it has. Intent allows us to use it as messages. So, for example, I need to load whether I just push this intent that I need to load something, or, for example, refresh weather. Actually, on production, it could be simplified, and I can just use one intent, but just for demonstration, I decided to split it. Again, view model. The main difference is from previous view model. I mean, we have main method dispatch. So by using this method, we push some intent. So here is the demonstration. How can we handle it? For example, load or refresh weather. So as you can see, it is just one intent, but again, I just simplified to demonstrate it. And yeah, when we receive something like load or refresh, we load this weather. And again, we just call our use case, map it. And yeah, also we have another method which allows us to update this state. Depending on its state, we simply update it, just one property state, and call modify listeners, which allows us to redraw the structure. And by using this context watch, as you can remember, it is connected with the provider. I listen to the state which is being redrawn. So yeah, when it's changed. Here is the strength of this approach. So again, testability, strong composition, riverpod, scalable state management, immutability and predictability, and directional data flow, as I demonstrated you with these scheme. And talking about its weaknesses, here is, but actually it is much better to use MVI than previous patterns because it matches much more with our stateful approach in Flutter. All right, let's go to Redux. Redux is a little bit harder to understand from my perspective, and as you can see, this diagram is a little bit more complex. It has an action which goes to our dispatcher, and by using this store, it allows us to update our view. And again, view sends some actions to our dispatcher. Let's review our state. It is actually almost the same as we had previously, just a couple of differences are connected with our method init loading. It allows us to set the default state of this state. So yeah, I just decided to use init loading, but it could be different. And another method, copy with, allows us to update this state. Here is the action. We have a couple of actions. It is highly also important to emphasize that these actions are used as from view as well as from other components. I will show you a little bit later. So yeah, fetch weather action, reload, again loading, weather loaded action when we received some data from network, obviously, and its error action. So here is the reducer, which allows us to handle its state. So yeah, it allows us to respond this state and handle this action. So when we receive action loading weather action, we copy. We call this copy with method and edit other properties. While it's when it is loaded, we just copy the state with a particular weather data model. And the same for error. The store allows us to make some kind of initial state of this structure, and also it allows us to bind other components with this structure. For example, I just put middleware. A little bit later, I'll show you what does that mean. But in general, it allows us to interact with the network. So yeah, this is the middleware component. Allows us to also handle some actions, as well as by using this fetch weather use case, as we used previously, allows us to obtain a particular weather data. And again, map. And then by using this store, we dispatch some other actions. So yeah. And here is the view page, which allows us to draw this structure, right? So on init, we just dispatch fetch weather action. Converter allows us to convert this store weather state into particular view model. And yeah, builder allows us to handle this weather, this full state, and draw this into UI components. Here is the view model, which has a couple of properties, and yeah, and just one method which operates with this with its store. So any questions here? Okay. Yeah, talking about Redux strength, it is clear, centralized, easy to write unit tests, and scales well in large applications. And talking about weaknesses, too much boilerplate for small apps. As I just demonstrated, we created a lot of components in order to show just a simple state, which is really complex. Not very Flutter-like in style, and overkill if app doesn't need global state. MVI. So this structure is pretty the same. Sorry, MVU. This structure is pretty the same. We have a cycled data flow. So yeah, we have some kind of current application state, which passed to renders its UI based, and then it could dispatch some messages to update this model, and again, this model goes to current application state. So here is the model. Actually, pretty the same as we've observed early. A couple of properties like loading, model, and error. And actually, that's pretty. Copy with methods as usually we used for updating this model. There are some messages. So yeah, by using these messages, we interact. Our view interacts with other update components by using these messages. So again, for example, I need to fetch weather. I just call this fetch weather message, and it goes to the next components. Here is the handling of these messages. So yeah, again, we have the switch case structure. This message goes to this method update, and yeah, when I need to fetch weather, I just set our model that loading process goes, then I fetch weather again by using this use case, map it, and update our model by using this setModel method. When it goes to weather loaded, I update that I already have some data, and if something went wrong, I update this error. Here is our notifier component. This is another one. I just here find our other components, put this updater, which allows us to call this method update. And yeah, the first message is fetch weather, as I need to fetch it. Yeah, set model as usual, and dispatch allows us to again update these messages. And here is the view. So again, I just by using context watch this weather notifier, and when it's being updated, our structure is being redrawn. Yeah, here's the strength. So again, immutable state, simply like the same as MVI pattern. Directional data flow, actually the same. Clear separation and encourages testability, actually almost the same. When it goes to weaknesses, so yeah, again, just from my personal perspective, it is not kind of like Flutter style. In the meantime, it could be recognized for like simpler applications, like for MVP or something like that. And BLoC. Here is the diagram, which actually has similar structure on directional flow of data. So BLoC has some kind of state, which has event, which allows us to update our UI, which can interact with BLoC BLoC. So again, that's some kind of state. Not actually much to say here, just the same states as we've already observed earlier. Here is the event. So this event interacts only with it goes from view only. So yeah, I just have one because I just need to get weather event to get weather. Yeah, here is our BLoC structure. By using this on method, we can listen to particular events. So this example demonstrates. So we listen to this get weather event, rather emit that we keep some kind of loading and emit this weather loading. And yeah, again, fetch weather by using this use case, map this and emit that we responded something. So weather loaded allows us to do that. The same weather error when we have some kind of error. And here is the view. So we have special block builder component, which allows us to simply watch for context and state. And here is the sample of how we can handle these states. So weather loading allows us to so we know here that something is in progress, and we appear circular progress indicator. While we have weather loaded, we just update our structure by using this refresh indicator component. So here is the strength. So again, scalability, clear separation, highly testable. So yeah, I agree, but it is highly important to say that we have a big community with Flutter BLoC. Actually, it has a lot of libraries, such as, for example, Qubit. We can hide a lot of boilerplate code by using these libraries. So yeah, it is a really cool thing. And reactive programming fits well with Flutter widget system. Talking about weaknesses, yeah, kind of boilerplate However, again, we can hide some boilerplate code by using these separate tools. Steeper learning curve for beginners. So yes, but actually, as I demonstrated you previously, other patterns also could be some kind of challenging for beginners. For example, Redux, it is much more complex. And yeah, it can be overkill for small apps or local state, but we are talking about for such kind of applications, which should be more scalable. So yeah, unfortunately, here something wrong with illustration. So yeah, this is actually our comparison of the patterns. So as you can see, Viper, MVP, and MVVM. These patterns actually are not highly recommended to use for Flutter. So yeah, and this table illustrates sorry. And this table illustrates some pattern which I could recommend to use. Especially, I want to emphasize about MVU and BLoC. Talking about Redux or MVI also can be, but it could be quite challenging to support in future. So here is this project. I published it to GitHub. It could be simply cloned and play with it. And this is my LinkedIn. So if you want to connect with me, please don't hesitate. So if you have any questions, please don't hesitate to ask me.
In the chat, there's no questions.
Okay.
So, and I don't have one, two.
Okay, cool. So, okay, again, thank you for your attendance. It was really interesting to explore just for me personally. And of course, it was really interesting to demonstrate on how it could be how it could be used, and so on. So in this point, we can finish our session.
Yeah, I think so.
All right.
So, thank you very much.
Thank you.